And welcome, my friends. Today we are talking hurricanes, typhoons, tropical cyclones, and all things like that. We'll give it about a minute or two as folks join in right now. I know we're coming to you right at 1 o'clock, but we'll give it maybe 1 or 2 more minutes. We are so happy to have you here. We're talking all things hurricanes, typhoons, and tropical cyclones. Of course, hurricane season starts up on June 1st and really gets going around August or September, but never too early to learn about hurricanes, how they behave, what they are, and how to prepare for hurricanes as well. So thank you so much to the folks tuning in right now. We are waiting about 1 or 2 more minutes as our audience increases and we start getting people here. Thank you so much for the folks tuning in right now. We are so glad to have you. We'll give it about 1 or 2 more minutes as folks start to trickle in. We're talking all things hurricanes, so come with questions. We are so happy to talk about any questions you may have regarding all things hurricanes. And, well, like I said, we'll get going in about 1 minute, so come with questions. I'm just pulling up the stream on my phone as well so I can see your comments in real time so I can answer your questions and have any information that you might need. Holden, age 7. Holden, so good to see you. Thanks for being here. Lauren, age 10. Zach, age 8. Yeah, great to see you guys out in Glen Allen. Very nice. All right, we'll give it about 30 more seconds. I see about 61 people watching right now, but I know that number will trickle upwards in a little bit as we continue talking about all things hurricanes and tropical cyclones. I will admit there's a lot in this presentation. Don't know if we'll get through all of it today, but there's so much interesting information about hurricanes we can talk about. And of course, Amanda Baker's son, third grader Matthew, a shout out. Hi, Matthew. It's one of my favorite names. My name is Matthew as well. Kyle, it is so great to have you. Leslie, we'll talk about typhoons as well. Emma, age 6. Emma, really nice to see you. Thanks for being here. Alia, age 11. I hope I said that correct. Chase is 11 years old as well. Great to see you, Chase. Avery, good to have you as well. Thanks for being here. And Eddie is 9 years old. Daniel, age 7. Good to see you. Daniel Benedict, very nice. And Chaitanya, yes, very nice to see you as well. James Cameron. Alrighty, I think it is 1 o'clock on the button. Ben from the Woodlands, Texas. And Jason, good to see you as well. All right, without further ado, I think we will get going with hurricanes. So without further ado, talking about what hurricanes are, how they form, and of course, what makes wind. That's a tricky one. You know, we see wind all the time. We feel wind when we go outside. But what is wind? We understand that it's moving air, but why does the air move? We'll talk all about that. What is storm surge? Storm surge, one of the most dangerous things about a storm. We'll talk what it is and why it's important to forecast and to avoid as well. And what's the eye of a storm? It seems kind of weird that some of the most powerful storms on the planet have this little empty eye in the middle. We'll talk about that. And one other thing, hurricanes can produce tornadoes inside them. You have a storm inside a storm. That makes it even scarier. Dana, Tyler, Noelle, Rachel, all watching Noelle's 9th birthday. Congratulations, Noelle. That's awesome. Everybody wish Noelle a happy birthday. That's great. She's turning 9 today. Addison, age 7. Caroline from Arlington as well. All right, so big question. What are hurricanes? This is a hurricane right here. It looks pretty crazy from space, and that little hole in the middle is actually a hole in the storm. That is the eye. Hurricanes usually are about 200 to 1,000 miles wide. Think about how big that is. That's probably bigger than the state in which you live. They're very, very big. Now, tropical storms are like hurricanes, but they're weaker. Hurricanes happen when the winds get to 74 miles per hour. That's faster than you drive on the highway, hopefully, unless you're my dad. Hurricanes are storms that form over the tropics over warm water. Hurricanes don't really form in the wintertime. They don't form in cold weather. They form when the water is nice and warm, almost as warm as a bathtub. They're most common in tropical areas because tropical areas are the warmest and they get the warmest waters as well. And like I said, they can be 200 to 1,000 miles wide. Now, you might hear different names for hurricanes. Some people call them typhoons if they're in the Western Pacific, impacting places like Japan, China, Philippines. Some people call them cyclones. I believe Australia calls them cyclones as well. So every part of the world has a different thing they call them. India calls them cyclones as well. In the United States, we call the stronger ones, anything more than 74 miles per hour, a hurricane. Now, hurricanes love warm water. I like warm water too. It's nice to swim in, nice and warm. But just like you would get down in the tropics, they like nice warm water over 82 degrees. That's kind of the threshold. 82 degrees, very summery. Emma will talk about your question, how long hurricanes can last. Edmondo, age 10, what happens in the eye? Yeah, we're going to talk all about that, Edmondo. Very good question. But hurricanes like warm water over 82 degrees. If you don't have temperatures reaching that threshold, you really won't have a hurricane form. Now, in order to get a storm to form, the waters have to be warm, and that means the air near the waters is warm as well, and that causes the air to rise, and you get water to evaporate. So little pieces of water fly from the ocean in gas form up into the sky. We can't see them, but eventually they fuel storms, they help produce rain, they help produce wind, all of that stuff. And so the moisture in the atmosphere and the warmth is key to developing a storm. We start off with something called a tropical wave. When enough air is rising, you get clouds, you get downpours, you get some thunderstorms, like these ones right here. Look in the right side of the image. On the left, that's South America. On the far right, that is Africa. And you see that kind of cluster of cloudiness on the right side of the screen. We call that an African easterly wave. They're tropical waves, so big bunches, clusters of shower and thunderstorm activity that move off the coast of Africa and start to meander west. And that's what starts a hurricane. They're usually big clusters, sometimes 500 miles wide, but they're weak. They don't really have any wind yet. But if conditions line up right, they can grow into big, scary hurricanes. The other interesting thing, tropical waves can only develop if winds in the atmosphere are weak. It might surprise you to learn that in order to form a hurricane, hurricanes being known for their strong winds, you actually have to have weak winds before the storm. That's because, think about it, if you have too strong of winds, then the whole thing will be pulled apart. Now, about 40 to 60 tropical waves develop each and every year. Most of them are weak. About a quarter of them or so become hurricanes. In order for the winds to strengthen, and in order for a hurricane to grow, it has to blossom in an environment that has light winds otherwise outside the storm. Not all that impressive. Any change of wind speed and direction in the upper levels of the atmosphere can actually tear apart a storm. So think about tug of war. You have this right here. Imagine if you had a cloud in the middle and two different groups pulling the cloud in different directions. Eventually, the cloud will be sad and probably fall apart. The same thing is true with hurricanes. If you want a storm to grow, you can't have those strong winds. You can't have a tug of war. You can't have clouds being pushed and pulled in different directions. The winds need to be weak enough that clouds can grow without being bothered. Otherwise, they fall apart. And eventually that will produce this. The tropical wave will start to spin. Now, once a tropical wave has developed enough, it does start to spin, and then the winds can increase. Most tropical waves are between 200 and 500 miles wide. They're also very tall, about 30,000 or 40,000 feet tall. The thunderstorms and showers in a tropical wave can be as tall as when you ride in an airplane. Now, Imran, age 6, asks, how hot does the water have to get? We like temperatures to be about 82 degrees or warmer. Allison is a 3rd grader from Maryland. Allison, so good to see you. Thanks so much for being here. How much percent does a hurricane stay in water? I'm at age 8. Hurricanes can actually only grow over water, so almost all of their life is over water. Only when they do move ashore do they cause damage on land, but otherwise, that's when they start weakening. So hurricanes actually weaken very quickly when they move ashore. They can only intensify over the water. Anna, age 11, asks, have there been any Category 5 hurricanes recently? 6 of them in the last 4 years. We'll talk about that in a few minutes. Now, I have a question. Can anyone guess, why do hurricanes spin? We know they're big storms, but why do they spin? That's kind of a tough question. Why do hurricanes spin? Well, I'd like to answer that question by asking you, have you ever ridden a merry-go-round? That will be key in just a second. Hurricanes spin because the Earth spins. Anything on Earth that is big enough will feel a force that makes it want to spin. It's called the Coriolis force. Anything in the northern hemisphere wants to curve to the right, and that means all the winds curving into a hurricane curve to the right, and they spin counterclockwise, or opposite the way a clock spins. Now think about this. If ever you've been on a merry-go-round, you've probably maybe felt a force that makes you want to fling off the merry-go-round. If you tried walking in the merry-go-round, you'll realize that's tough. Now imagine this. You're on the merry-go-round, you're sitting with a couple of your friends, and you push a ball across the merry-go-round. It looks like it's going straight, but if you're on the merry-go-round, it actually looks like it's curving. And that's kind of the same effect as to why hurricanes spin. Because the Earth is spinning, it appears the winds are spinning as well, and indeed they are. They actually spin in circles as well. That means anytime something in the northern hemisphere moves and wants to curve to the right. If you could launch a rocket from the equator towards the North Pole where Santa lives, eventually that rocket would curve to the right because the Earth is moving inwards and it starts curving more and more to the right. If you were at Citizens Bank Park in Philadelphia and you hit a home run baseball, that baseball, if it was traveling fast enough and far enough, would actually curve 2 inches to the right of a straight direction. So it even affects baseballs. Now, if you look at this is Hurricane Dorian last September. You see the yellow is the way the winds want to go. The red is the way they actually go. You can see they all curve to the right inside the storm, and that's why storms spiral counterclockwise in the northern hemisphere. South of the equator in Australia and South America and South Atlantic and places like that, any storms that formed would spin clockwise, so the opposite direction. That means on the equator, you can actually have no hurricanes. You're safest from any big, scary hurricanes on the equator, which might seem kind of strange because the equator is where it's usually the warmest, the moistest, and you have the warmest water as well. Now, why does air flow into the storm? Why is air not coming out of the storm? It's only going in at the low levels of the atmosphere, and the winds are flowing in. Well, let's talk about that. I want to think about dams. Dams have more water on one side and less water on the other side. More on one side, less water on the other side. Now imagine we made a fish tank. We had 2 fish. Oh, look, it's Nemo and it's Dory, my 2 favorite. Let's pretend we had a fish tank and we put a wall in the middle of the fish tank. And on one side where Nemo lived, we put a lot more water. And on the other side where Dory lived, we put less water. Who loves Nemo and Dory? They're 2 of my favorites. But we have more water on one side and less water on the other side. Now let's pretend we lifted up that wall in the middle. Eventually, the water from Nemo's side would slosh over towards Dory's side, and the difference would equalize. Then both sides would have the same amount of water. The same is true in hurricanes. Because warm air rises in the middle of the hurricane, you have less air in the middle of the storm. That means it pulls air from the outside to equalize that difference. Air is drawn in the middle. As it gets closer, it's faster and faster, just like water going around a sink or down a sink drain. And that's why the winds get fastest towards the middle of the storm. Any questions so far? Any questions so far? How many hurricanes have there been in the USA in the past 10 years? Eddie, age 9, great question. You know, the past 10 years had been rather quiet until about 2015 or 2016. Then all of a sudden, we got storm after storm after storm. And so we've had, I want to say, 6 or 7 major hurricanes impact the United States in the past 3 or 4 years. Prior to that, it was actually somewhat quiet. Robin likes the Nemo and Dory analogy. I'm glad, Robin. Which hurricane has cost the most money to repair? Harvey and Katrina both tied for the most amount of damage in the United States in terms of a dollar amount, which is kind of interesting because Harvey did most of its damage from flooding. You know, most of the damage from storms doesn't come from the wind. It comes from storm surge, water moving ashore, and rain inland. Valerie says we are glitching here. Well, I hope the stream recovers. We shall see. Let me know if there are any issues hearing me, if anything like that. I know that Wi-Fi can be kind of tricky sometimes, so we'll see how things work out. Let's see. And we will move forward a little bit. Let me just adjust my stream to make sure that we are getting the best internet that we can. And otherwise, we're going to move on. So I want to show you a cross-section of a tropical cyclone. Let's see, here we go. My apologies, just 1 second while I fix the stream. We're having a quick little technical glitch. Just want to make sure I can see all your comments because you have such great comments and I would love to be able to respond to them in real time. Let's see. Here we go. Awesome, it's back. So in the middle of the storm, we have air rising in and spiraling quickly. The tallest thunderstorms are towards the middle of the hurricane. In the eye, so much air rises just outside the eye that some of it falls back down in the eye and pushes down. And because the air pushes down, you actually can't have any clouds grow in the middle of the hurricane in the eye. And that's why it's clear in there, which is really cool. It's just like in the middle of a sink. All the air spirals and it gets faster and faster and faster. The most intense movement, the most intense winds will be found closest to the center. Outside the eye is the eye wall. That's where winds are the strongest, the rain is the heaviest, and you can even get tornadoes in the eye wall. The eye wall is closest to the middle of the storm. Now we rate storms based on something called the Saffir-Simpson hurricane scale. Tropical storms produce winds up to 73 miles per hour. Once winds reach 74, then it's a hurricane. Hurricanes can be major hurricanes if the winds get faster than 111 miles per hour. Category 5 storms produce the worst wind at 157 miles per hour or more. Megan wants to know, why do they name hurricanes in alphabetical order? Well, Megan, we have a 6-year list of hurricane names. Your name might actually be on there. Many people can check to see if their names are on there. That way, we can recognize each storm and track it over time. The National Hurricane Center and the World Meteorological Organization team up to come up with hurricane names. If a storm produces lots of damage, they get rid of a name and they don't use it again. Hurricane Katrina, that name was retired, so no more Katrinas. It's since been replaced with Katia. How big can hurricanes get? Typhoon Tip, which was a hurricane in the Pacific, reached almost 1,000 miles wide. Now, I want to talk about Category 5 hurricanes because those are the wildest. We'll talk about Maria in a little while. Maria was a Category 5 storm that I believe caused Category 4 damage in Puerto Rico. It was awful. This was Hurricane Michael back in October 2018. It was a Category 5 storm. Here's a satellite image. Look how big it is. Close to 400 or 500 miles wide. And you can see that swirl as air moves in at the lower levels and flows out at the upper levels. But look at the eye. It moves ashore and it starts to fill in as the storm weakens. But it still was a Category 3 as it moved into Georgia. Here's that eye wall moving ashore, approaching Tyndall Air Force Base in Panama City in the Big Bend of Florida. You can see it's clear. You can actually see the ocean down below. And there it is, the eye wall, the craziest wind and the rain and all that stuff right around the eye of the storm. At this time, winds were gusting over 160 miles per hour inside the middle of the storm, or just near the middle of the storm in the eye wall. And then it moves ashore. And watch right now, you can actually see the beaches of Florida in this satellite loop. You see right there, it moves ashore, on that satellite moves inland. And people inland went from 160 mile per hour winds to clear sky. Only eventually, once the storm starts to weaken, does the eye fill in. But incredible satellite loop showing you how intense that storm was. Here's a radar shot of the eye wall. All around, you see the big yellows. That was a Category 5 hurricane as it moved ashore and brought extreme winds over 150 miles per hour to Panama City. And in the middle, clear and calm. Jack wants to know how many categories there are. Hurricanes go up to Category 5. Anything with winds more than 157 miles per hour is a Category 5 storm. Dorian had winds of 180 to 185 miles per hour. We'll talk about Dorian in a moment, but they go up to Category 5. Leslie wants to know, where was Hurricane Michael? That was back in Florida, back in, I believe, 2018 in October. Dennis wants to know what the worst hurricane was. Katrina caused a lot of damage, even though it was not the strongest hurricane. I believe it was, let's see, who tied? Dorian and one other storm, maybe it was Ivan, tied with 145 mile per hour winds. I'm sorry, with 185 mile per hour winds. And the winds can do incredible damage. Look right here. These are the winds from Hurricane Michael as it moved ashore in Florida. These areas didn't even see the wind produce storm surge, meaning that no water raced ashore, but instead all that damage, just like a tornado from a hurricane. It was huge. Now, the winds from a hurricane can also produce storm surge. Storm surge is very damaging. That's what happens when all the wind pushes water up against the coast. And sometimes you can have up to 20 feet of water race ashore. That means anyone who lives less than 20 miles above the ocean will get all wet, and their homes could be destroyed from a wall of water that moves ashore. Storm surge is one of the most damaging and destructive and dangerous parts of a hurricane. That's what happens. You can see some houses and boats picked up and thrown inland. This was storm surge from Hurricane Michael. Far inland, you see a bunch of trees denuded and twisted and all that stuff from the wind. But near the coast, look, someone ended up with a boat in their front yard because they lived close to sea level and all the water was pushed ashore. This is what it looks like inside the eye of a storm. We have hurricane hunters who fly into the storm to try to learn as much as they can and help us to better understand just how fast the winds were. That was Hurricane Katrina. Katrina was Category 5, Jessica, but moved ashore as a strong Category 3. What really happened, it was mostly the flooding that caused the damage when the levees were breached by the extreme storm surge associated with Katrina. But this is what it looked like inside the eye of Dorian, another major hurricane. This is also what it looks like when a hurricane moves ashore. Someone asked a question about radar earlier on. We don't have radar over the ocean. Instead, we only have radar near land. This was Category 4 Hurricane Harvey moving inland, and radar helped us to see this shot of how tall the clouds were, about 30 to 40,000 feet. Now, in the past 4 years, we have had 6 Category 5 storms over the Atlantic. I know someone was asking about that earlier on. 6 Category 5s. We had Irma and Maria back in, I believe, 2017, Michael in 2018, Michael in 2015, or 2016, I believe, and then Dorian and Lorenzo. But 6 Category 5s in only 4 years. It's been extremely active in the Atlantic, and we've never had a stretch this busy. This is what Dorian looked like. Look at that razor-sharp eye in the middle. The satellite was incredible. You can see wind spreading outward at the upper levels of the atmosphere, inward towards the middle, and it just sat and spun in the same area for 45 to 48 hours at a time. Only then did it eventually expand and move up the coast as it started to weaken. But Dorian was one of the strongest Atlantic storms ever recorded. It was absolutely unbelievable. It rapidly intensified. It had winds of 180 miles per hour with gusts of 210 miles per hour on September 2nd as it moved ashore on Great Abaco in the Bahamas. Here's that satellite loop as it approaches making landfall. It was still rapidly intensifying and strengthening at this point. Now, Rebecca wants to know, how big is the average eye of a hurricane? Well, it's about 10 to 30 miles wide. Sometimes you get bigger ones. Hurricane Lee, I believe, produced a pretty big eye. Other times, with Hurricane Wilma, for instance, you can have eyes only about a mile or 2 miles wide. We still don't really understand what determines the size of an eye, but we do know that big storms oftentimes have clear eyes. That's a really surefire sign of strong winds. Now, some hurricanes and tropical storms can even produce tornadoes. We had Hurricane Ivan and Hurricane Beulah back in 1967 drop more than 100 tornadoes. Dorian produced this tornado that moved ashore in portions of coastal North Carolina. It was extremely intense. This was Hurricane Ivan that spawned a tornado back in 2004. This was in Virginia, near Remington, Virginia. And so even if you don't live near the coast, any hurricanes or tropical storms that move ashore can produce tornadoes in their rain bands. Sometimes you can even have tornadoes in the eye wall. Look in the far right. That's a signature that shows you have spinning winds, mesovortices, little eyes within the eye, and sometimes those can produce tornadoes. Hurricane Harvey produced numerous tornadoes, over 30 to 40 of them, I believe, and you can see the remnants of Harvey as they moved inland prompted tornado warnings in many areas. It's very difficult to predict where tornadoes will occur in tropical storms and hurricanes, but we do see that they often occur on the front right side of the storm. Another interesting thing, some storms produce lightning only in the eye wall. Dorian produced lightning only in the eye wall. But for reasons we still don't understand, at the upper levels of the atmosphere, you can have crazy lightning called transient luminous events, giant lightning at the upper levels. Here's what that looked like back in August 11, 2015, as I believe, was it Hurricane Lane? Let me double check on that. Hurricane Hilda was approaching near Hawaii. Look in the far right. This is very far away. You see these big bursts of red as bursts of electricity shoot in the upper atmosphere. These are called sprites. And eventually you even have what are called jets mixing in too. Jets are a special type of lightning that shoot out from the top of thunderstorms. They're extremely rare and tough to photograph or see. But look at that. You have sprites leaping out the top of the storm. Here are some jets seen the very next day, far from the storm. And bam, jets shooting out the top of a storm. Now, most hurricanes don't produce ordinary lightning, but for reasons we still don't understand, some of them, despite producing next to no ordinary lightning, can produce crazy firework lightning in the upper atmosphere. Frank Lucena caught this picture of sprites from Puerto Rico during Hurricane Matthew. in 2015. Of course, Matthew was far away at that point, but because the lightning was so high in the upper atmosphere, we were able to see these. Any additional questions, do let us know. I know we have many interesting things we're talking about. Happy to answer your questions. Let's see. We had one question from Kirsten. She wants to know, does the size of a storm or does the size of an eye matter how intense the storm is? You know, most strong hurricanes produce razor-sharp eyes with clear or clearish skies in the middle, but we still don't really understand what determines the strength, or rather the size, of the eye of the storm. It's extremely tough to predict. So the size of the eye doesn't really have bearing as to strength, but whether or not the eye is clear and intense really is correlated well with strength. Any other questions? Do let us know if you have any questions. We are happy to answer anything you might want to know. So example, just for you, Kirsten, this was Dorian back in 2019, September, and you can see that razor-sharp eye and the very cool, dark cloud tops. This is a special type of satellite that shows us the temperature of the cloud tops, and the darker colors indicate cooler cloud tops because they're so high up. And you can see this extremely intense eye is associated with Dorian as it makes landfall, or as it approaches landfall on Great Abaco Island. Now, Jennifer wants to know what the difference is between hurricanes and typhoons. Typhoons are just hurricanes that occur over in the Pacific. So certain parts of the world call them different names. Typhoons occur in the Pacific. Cormac, age 10, wants to know what was the largest hurricane ever. Typhoon Tip, like a hurricane, occurred, I believe, back in the early 2000s over in the Pacific, and it was close to 1,000 miles wide. Megan wants to know, why is it red? So the storm wasn't actually this color. Instead, we have a satellite that can sense the temperatures of cloud tops. And what you see right here, the cloud tops were very cool, and so they're plotted as dark and red, which is pretty interesting. Now, hurricanes and tropical storms can also produce inland flooding as well because they have such intense rains. This was from Hurricane Harvey back in 2017 in Houston. It wasn't even a hurricane when it produced its most rainfall. Instead, it was a tropical storm with winds of only 40 or 50 miles per hour. But because tropical storms are tropical, they have such tropical moisture, they can drop extreme rainfall. Like this. This flooded Houston. Here's another shot. Just amazing flooding associated with that rainfall in Houston. Here's one more shot showing you exactly what it looked like. Some places saw over 60 inches. That's 5 feet of rainfall. Nederland, Texas picked up 60.58 inches. We had 4 million people see more than about 4 feet of water. It was absurd to think that much rainfall could form and fall with a tropical cyclone. That's 152.4 centimeters, or in other words, 60.58 inches you see right there. Forgot to change things back from metric. But that's how intense that rainfall was from Houston. Now, most of the deaths that occur in tropical cyclones actually occur from rain and freshwater flooding. Almost 2/3, about 3/5, so 60%. And that goes to show you, it's not just the wind near the coast. It's not just the surge near the coast. You can be seriously impacted by a tropical storm or even a hurricane inland just from the amount of rainfall you get, which is extremely important. Florence, back in 2018, produced exceptional rainfall, up to 40 inches in the Carolinas, and that resulted in widespread damaging and even some deaths. Did people drown, Theodora? Yes, unfortunately, there were deaths from people trapped in automobiles and drowning, which is why you never should travel through flooded roadways in a vehicle. Turn around, don't drown. Megan, the water is so high? Exactly, yeah, it's super high. And in just one day, August 27th, 9 trillion gallons of water fell on downtown Houston. 9 trillion gallons. That's the same as if you had a block of water 2 miles by 2 miles by 2 miles. That's how much water fell in downtown Houston in just one day associated with Hurricane Harvey. And that's how intense it was. About 34 billion trillion, it looks like, liters. So extremely intense. Think about those smart water bottles. 34 trillion of those. Now, a storm doesn't have to be intense to produce extreme flooding. This was Imelda back, I believe, in September or October. I think it was October of last year. And you'll notice, doesn't have an eye, it's not all that intense. It only produced winds of about 45 miles per hour at worst, but it produced extreme rainfall, up to 45 inches of rain near Port Beaumont and Port Arthur in Louisiana, 45 inches of rain in some locales. And that goes to show you, It's not an intense storm, doesn't have to be an intense storm, but it dropped up to 45 inches. Now, we also want to talk a little bit about climate change. If we have any questions so far about flooding, about hurricanes, anything like that, do let us know. And of course, if you have friends who might be interested, tag them. Share this with your friends. Share this with your classmates. I know a lot of folks can't go to school right now because of what's going on in the United States. So we are happy to try to give you this little extra bit of science. And if you know anyone else who might be interested, do let us know. We are so happy to talk about that as well. So climate change is also affecting hurricanes. It's making them wetter. For every degree Fahrenheit the air warms, thanks to climate change, the air can hold 4% more water. And that's making tropical storms and hurricanes even wetter. And that's resulting in more flooding, like what we saw back in Harvey, back in Houston, back with Imelda as well. So the warmer the world gets, the wetter the world gets, and the better the chance we'll see more flooding storms in the future. Now, we're not seeing more hurricanes thanks to climate change. Worldwide, every year, we'll see about 90 tropical cyclones, hurricanes, typhoons, cyclones, things like that. We're not seeing any more of them, but those that form are becoming more intense thanks to climate change. They're also rapidly intensifying more. Rapidly intensifying means they increase about 35 miles per hour in wind in 24 hours. So you can have a big jump from a tropical storm to an intense hurricane in only a day or less. Like this, Super Typhoon Hagibis, back between October 6th and 7th, 2019. It was the fastest intensification in the West Pacific in 20 years. Here's a satellite shot. It went from a tropical cyclone, or rather a tropical storm, to a Category 5 in just 24 hours. And look at that satellite loop. Nothing, and then all of a sudden it gets tighter, and look now, an eye is forming. These are only 3 hours apart, and as it approached Saipan and Micronesia, it became an intense Category 5 after just having been a tropical storm only 24 hours earlier. Same thing, here's that shot as it became an extremely intense Category 5 equivalent super typhoon. And there's that razor-sharp eye wall as it moves north, extremely intense. Genevieve, thank you, I appreciate it. Susanna, yes, it is absolutely possible for a hurricane to have no eye. Some have very small eyes, some have no eyes whatsoever. Now, another thing I want to talk about, there's some evidence to suggest hurricanes might be slowing down in speed and stalling over the same area for longer. Here was Dorian. Dorian sat over the same island chain for close to 2 days. Some places saw Category 3 or worse winds over 111 miles per hour for upwards of 18 hours. Can you imagine being under tornado-like wind speeds for over 18 hours? That's what caused such damage in Dorian. Now, 24 hours apart, you see the star right there. The star is in the same place on the eastern part of Grand Bahama Island. This was during Dorian. 24 hours, and that star is still in the eye wall of the storm, seeing extreme winds over 100 miles per hour. So it just goes to show you that as the world gets warmer, it's going to get wetter, storms will become increasingly strong. And one other thing that I should look at really quickly if I can, hurricane names. Atlantic hurricane names. I forgot to include that, but I know a lot of people want to know if their names are on the list. Now, fortunately, we have a rotating list of when storms will be named different things, and I can actually try to pull this list into my PowerPoint real quick, and we'll get this list for you so you can see if your name is on the list as well. And let's see, just one moment. So the National Hurricane Center uses a 6-year list. And this is what that list looks like. So in 2020, we'll have Arthur, Bertha, Cristobal, Dolly, Edward, Faye, Gonzalo, Hannah, and eventually down the road, we'll keep in 2021 introducing new names and more names in 2022. But that means the same things we have in 2020 will be the same in 2026 and 2032, unless the storm causes so much damage that they get rid of the name. So it's all dependent on how much damage occurs. So you can see if your name is on there, anyone named Lisa, Larry, Laura, Josephine, Hannah, Gonzalo, Faye, Aaron, you guys are on the list. So your names might be used for hurricanes. My name can't be used anymore because as a result, Hurricane Matthew in 2015 caused so much damage that unfortunately, well, fortunately, they're getting rid of the name, but that means there will not be any more Hurricane Matthews. Valerie says, hurricanes are my second favorite type of extreme weather. Thunderstorms are my favorite. Yeah, we'll talk more about thunderstorms next week. How many pictures have I taken of hurricanes, Leslie? I actually have not really done much hurricane chasing. Joy, great question. Can a hurricane ever have more than one eye? That's from Imran, age 6. Phenomenal question. A hurricane cannot have more than one eye because that means it would have to have multiple centers. And unfortunately, you cannot have that. Hurricanes only have one center that they're kind of anchored around. And it's kind of like a chimney. All the warm air goes up in the middle of the hurricane. And so hurricanes can only have one eye, not more than one eye. Imran, great question. Let's see. Theodora, age 7, asks, how fast is a hurricane? Well, we talked about how winds in a hurricane can be up to 180 miles per hour. Sometimes hurricanes can move forward at about 10 to 20 miles per hour. That's most common. But on rare occasions, they have moved up to 70 miles per hour forward speed. And that makes their winds even stronger. Back on September 21st, 1938, a hurricane moved into New England, Massachusetts, Connecticut, Rhode Island at speeds over 70 miles per hour. So even though its rotational speed was only 110 miles per hour, it had winds over 180 miles per hour gusting at times, which gave it Category 5 like damage and a 20-foot storm surge that roared ashore in southern Massachusetts. Jennifer wants to know, have we ever used more than 26 names in a year? So have we ever run out of hurricane names? Indeed, we did back in 2005. We ran out of names, and eventually we actually had to use a Greek alphabet. So alpha, beta, theta, delta, epsilon. And so we had so many storms that year that even extended into December, which was extreme to see. We had hurricanes in December. I think there might have been one in January of 2006. So as that extreme hurricane season, the same season that produced Katrina, continued onward. Christine, my name is not on the list. I'm sorry to hear that, Christine. Kelly wants to know, can more than one hurricane combine together? Yes, you can have something called the Fujiwara effect, when two hurricanes or two tropical cyclones orbit around one another. Eventually, if one starts to weaken, its remnants can be pulled in and eaten by the other cyclone. Pretty interesting. Anna wants to know, how do scientists get into the hurricane? Well, it's possible to fly into a hurricane. We fly in strong winds all the time. If you're on Delta, American Airlines, anything like that, you're actually flying through strong winds, but the airplane just doesn't really feel it like that. So it's possible to fly into a hurricane. The danger is not how fast the winds are. The danger is actually when you have updrafts and downdraft, air moving upwards and downwards, and that can actually cause the plane to move up and down. And if you're flying close to the ground, that can be dangerous. Ben, how long can hurricanes stall? We've seen hurricanes stall in the case of Harvey and Houston for close to about 3 or 4 days. And unfortunately, it looks like we'll have more stalling storms in the future. What is the rarest hurricane? Megan, I'm not exactly sure what you're asking. Category 5s are, of course, the rarest, just because you're kind of at the top of the pyramid. But if you have a more specific question, I'm happy to answer that as well. We'll take about 2 or 3 more questions as well. So any questions, do let us know. We are happy to answer your questions. And if you have questions later on, you can always write those in. I'll do my best to answer those. We'll have members from our team, our engagement team, try to respond to those as well. Christine, what's the rarest hurricane? Let's see. Oh yeah, Laura, great question. So I was mentioning that hurricanes sometimes stall over specific places, just like Dorian did, just like Harvey did. What causes that? Well, hurricanes are steered by winds at the upper levels of the atmosphere. And so if the winds at the upper atmosphere are weak, or if there are no weather systems nearby to influence those winds, there really won't be much to steer the hurricane. Instead, you'll just have the hurricanes kind of sit and stall, and that's exactly what happened with Dorian. Unless there's something to move it around, it doesn't really want to move. Now, eventually, as hurricanes move north, they start to curve to the right more, thanks to the Coriolis effect. It's called recurving, and so they move out to sea oftentimes. Sometimes they can curve up the East Coast, just like Sandy did, just like Irene did, and so those are dangerous. And of course, even in New England, even in Washington, D.C., we have to watch hurricanes as well. And Emmett, I don't believe there is a Hurricane Emmett. I'm sorry about that, but hey, I guess that's good news, because you don't want a bad hurricane named after you. And with that, I think we're going to let you go. Thank you so much to everyone who tuned in. This was so much fun. I love talking about storms, and we are so grateful to the folks who tuned in. We're happy to answer any additional questions. If you have them, please write in. And with that, thank you so much for tuning in. We'll try to do more of these next week. We're going to be experimenting, seeing if we can do more different type of things next week. And with that, we appreciate you tuning in to Capital Weather Gang's Weather School. I will see you next week. Bye, gang.